The Labyrinth, Part 2. When I left off in the last video, I was talking about functional pairs. And the reason functional pairs are important is because one side is excited and the other side is inhibited. They have to happen in those pairs because if both sides are getting an inhibitory or an excitatory response, if both sides are getting the exact same signal at the same time, then essentially that would put us in this sensation of movement happening in both directions, so clockwise and counterclockwise, and that would be horrendously overwhelming to our brain. And so when one side is excited, the other side is inhibited, so that way the signal is telling me when I turn my head to the right horizontal canal is excited, the left horizontal canal is inhibited, so that way my brain gets accurate information about we turned our head to the right. Okay, so as it says up there, the horizontal canals are functional pairs. If you looked at the top of my head and basically drew an X, that is going to show the planes that the posterior and opposite anterior canal are aligned in. So this is my right side, okay? My right posterior canal and my left anterior canal lay in the same plane. And so when my right posterior canal is excited, my left anterior canal is inhibited. And so that gives me the accurate sensation of how my head is moving in space. And it's also important to note that these canals are only stimulated in particular planes, okay? So when I turn my head, not all three on the right side are excited at the same time. It's just whichever one is closest to the plane that my head happens to be aligned with at that time. So let me explain a little bit further more about that, how it detects that your head is moving at all. Okay, inside of each ampulated ending, you have a membrane called a cupula, and it's solid all the way through, but embedded in the cupula are these little hairs called cilia, and then the purple in this area is all endolymph. Now, the cupula and the endolymph have the same density or weight, and so they are not affected by gravity because, like, let's say for instance you lay back. Normally it would make sense that that gravity would pull the cupula down closer to the earth, right? Which would then cause this sensation of movement. But because the cupula is the same weight as the endolymph, it doesn't move at all. And so we don't get the sensation of spinning when we lay back. The caveat to that is when we drink alcohol is lighter than endolymph. Alcohol will infuse into the cupula first before it infuses into the endolymph, and so it actually will make the cupula lighter. So when we lay back, the cupula will try to float up through the endolymph, which just causes this displacement. And so that's why when you've been drinking and you lay back, especially with the lights off or when you close your eyes, you get this sensation of the room spinning. Ignore all the words on this side of the slide. I just really liked this picture for illustrating the action of turning your head and the endolymph's movement against the cupula. So when you turn your head, in this case to the left or counterclockwise, the endolymph then rushes around and pushes against the cupula. And so the cupula sort of billows like a sail in the wind because the endolymph is pushing against it. And then when that billows, it sends electrical signals to your brain that your brain interprets as, oh, we're moving our head to the left. So the functional pair of whichever canal is excited has the opposite effect, where it pulls the endolymph, moves away from the cupula, and makes it billow the other way. So the functional pair would do the opposite so that it's inhibited, so you only get the sensation of movement in one direction. Now, it's important to note that the semicircular canals don't pick up constant movement. They only pick up movements or changes in acceleration, so increasing acceleration or decreasing acceleration. That is why we don't perceive the rotation of the Earth, because that is a constant movement. Now, if the Earth suddenly stopped moving, we would sense that deceleration, and then if it started moving again, we would sense the acceleration. But because the Earth is constantly moving, we don't sense that movement at all. We only sense our movements relative to the environment around us. And so that's just an interesting fact. Alright guys, so tomorrow I will post videos about the otolithic organs, the utricle and the saccule, and they are responsible for picking up changes in acceleration or deceleration of linear movements, not angular movements.